Hi everyone, we're going to get started today with our independent lesson with regard to systematic substitution. So you have this document available in your independent work for this week, but I was going to walk you through the steps of using systematic substitution or re-engineering a question to figure out a missing variable. So if you remember the Pythagorean theorem from last week, we actually used systematic substitution, isolating the missing variable A or B or C to figure out what the missing one was. So first and foremost, our goal is to rearrange the expression to isolate the variable. In this case, the variable is going to be n. We don't know what it represents. It's just a mysterious number in order to solve what it represents. Let's say the question is 2n minus 1 equals 10. So our first step is to review the question. We have to understand what is it asking. 2n minus 1 equals 10. So in this case, the expression 2n, any number beside a variable, means multiply. Just like a number beside a bracket means multiply. So 2n means 2 times a number minus 1 equals 10. Now some of us might be able to figure this out in our head, and that's totally fine. But we want to use systematic substitution and rearranging the expression to basically rework the question so that n tells us what it is. And this helps out when you've got numbers that are maybe less friendly, less easy to solve off the top of your head. So in this case, the first thing we want to do is we want to get rid of everything on the left side of the equal sign until we're left with just n. So at the end, the question will read n equals whatever it's supposed to equal. So how we do that is we have to get rid of everything on the left side. So what I do is each line, I get rid of one thing, just to keep it really simple. I don't want to do more than one process per line so that I can slowly see in 5 steps every single individual piece that I re-engineered and reworked to be able to check my work later. So we get rid of everything on the left side. So we've got a minus 1. To get rid of negative 1, we could add 1. That would make it 0. Negative 1 plus 1 is 0. And you're allowed to do that as long as you do the same to the other side. Now again, this is what's called, this is what's called balancing an equation. We did this with the Pythagorean theorem. So we're allowed to take away this negative 1 here by adding 1 as long as we do it to the other side, because then the equation's still equally balanced. We're doing the same thing to both sides. And again, yeah, we can only do it if we do it to the same side. So if we do that, if we add 1 to the negative 1 and we add 1 to the 10, it gets rid of the negative 1 on this side and it makes 10 into 11. Now the next stage is exactly the same thing. It's a rinse and repeat situation. We have 2n, which is 2 times n. To get rid of a multiplication, we do the opposite. So I'm going to, instead of 2n, I'm going to divide 2n by 2, and that gets rid of the 2 on this side, which will leave it as just n, and I have to do the same on the other side. So 11 divided by 2 is 5.5. So n is 5.5. The last thing we want to do is check. So if we now input n as 5.5, I'm going to pull this up. So the question will look like this: 2 and in the brackets 5.5. 2 times 5.5 minus 1 equals 10. I'm going to just double check it up here. So 2 times 5.5 is 11 minus 1 is in fact 10. So that's how we use systematic substitution. If you have any questions, there'll be a discussion board as per usual for the independent work, and the independent work will be assigned attached to this video.